numbers going from minus to plus infinity. Okay? In the middle is 0. So you're going from 1 to 3, and minus 1, minus 2, minus 3, like that. All right? Sometimes people have problems with numbers. Okay? Now, the other thing about numbers is that numbers can be either discrete numbers or they can be continuous numbers. And when we decide whether we're dealing with discrete or continuous data, what we have to ask ourselves is my variable that I'm measuring a discrete variable or a continuous variable? Because it's not really the numbers themselves that are discrete and continuous, it's the variable that I'm measuring. Those are the ones that are discrete and continuous. So when you have a continuous variable, and you take measurements on a continuous variable, the precision with which you can measure is totally dependent on whatever instrument you're measuring with, right? So if I have weight as a variable, okay, I'm measuring the weight, right? A sack of flour, the weight of a car, right? The weight. The precision of my measurement is going to be totally dependent on the scale that I'm using, right? And you've seen those digital scales. You step on them and they give you your weights down to like the tenth, right? Or it's like every other tenth, right? So that they measure in 0.2, 0.4, 0.6, right? Some of them are even better, 0.1, 0.2, 0.3. So those are very precise, everyday kinds of scales, right? The scientists, chemists, right? Physicists, they use really, really terrifically precise scales, and they can go to several different decimal places for their weights, right? So if your variable can be measured with more and more and more precision, depending on the instrument that you're using, then you have a continuous variable. Then, if you can go out to several different decimal places, your position on the number line can be anywhere on the number line, and the only limit is your instrument, right? So with continuous data, with a continuous variable, that measurement can be anywhere on the number line. It can go out to a gazillion decimal places, as long as you have a precise enough instrument with which to measure that variable. Then you have continuous data. Discrete data are very different. With discrete data, the numbers can fall only at certain places on the number line. And basically, you're dealing then with whole numbers. So with discrete data, you can't have any position on the number line. You can only typically have whole numbers as your data. So they can't fall anywhere on the number line. They can only fall at certain points along the number line. So the kinds of variables that you're dealing with then in discrete data are things like the number of children you have. You'll always hear a statistic like the average number of children that families have in the U.S. is like 2.3 children. That was the average for years and years and years. Does that mean that somebody in some family has a third of a child, like they're missing their head or something? No. It's a statistical artifact, okay? You cannot have a quarter of a child. You cannot have half of a car, right? You can't own a third of a house, right? So we have these numbers that crop up every so often in studies, right? But they're just statistical artifacts. So with discrete data, your measurement can only fall at certain points along the number line, and you cannot have thirds and tenths and quarters and things out to 3 decimal places in reality, because what you're measuring doesn't come that way. It just comes as a whole, right? Like one bottle of water is a bottle of water if you consider the container, right? And that's the liquid inside of it. Okay? So is that clear? Continuous, discrete? You clear on that? Okay. The other thing that I just want to say, because this was a problem with my last spring class with a few people, and that's about rounding. Okay? If you have numbers like that, okay, and I tell you round to the second decimal place, okay, or numbers like 2, 2, 2, 4, 7, round to the second decimal place. What some people do, just go like that. They just lop everything off, okay? You can't do that, right? You have to round, okay? So this is going to round to 6.22, right? This is going to round to 0.16, right? You have to round properly. You can't just like lop off. Now, having said that, at the end of the next chapter, that's exactly what the book does. They just lop off the numbers at the end. But that's a particularly stupid example. But in exams, things like that, don't just like, knock off the last few digits, because those last few digits in statistics are important. They matter, especially for tables. Okay? Most of the tables you'll be using will be 2 decimal places, sometimes 3 decimal places. And if you're working at 1 decimal place or no decimal place, if you insist on rounding things as lost to whole numbers, depending on the problem on the exam, you may lose points for that, because sometimes your answer depends on those couple of decimal places. All right? So you want to learn how to round. Okay. All right. On page 12, okay, so make this note in your notebooks. When you get to page 12, you're going to have a little table there where they go over different types of data. Different types of data. So I'm going to put on the board what they have, and then we're going to flip it upside down and talk about it in a different way. So this is on page 12 in your book, and we go over different types of data. So they start out with what they call numerical data, and they break that down into magnitude data and rank order or ordinal data. And then they also have major trait with categorical or nominal data. And this is a nice little way of talking about types of data, except it's not what scientists use. It's not what scientists talk about. Scientists talk about scales of measurement. And why is it important to know the different types of data or the different scales of measurement that scientists use? Because what we're going to find is that the statistical tests that we're going to learn about are appropriate for one kind of data, one kind of scale of measurement, but maybe not for other kinds of scales of measurement, other types of data. They're used for particular kinds of data, but maybe not used for something else. Sometimes they're appropriate, depending on what you have. Sometimes they're not appropriate, right? So, this is what your book has. Again, this is on page 12 of your book. I'm going to go over very similar kinds of things, but the labels are going to be different, and I'm going to be going over things that are not in the book. Okay, so you want to take really, really good notes here. Okay? All right. The first scale of measurement we talk about is the nominal scale of measurement. And as your book says, this deals with categorical or nominal data. Okay, so this is a nominal scale of measurement. And again, it deals with categorical or nominal data. And basically, the question here is how many? How many? Not how much. How many? You're counting. All right? So the data that you have on a nominal scale of measurement or categorical scale, those are frequency data. Frequency data. How many of these do I have? All right? You're not measuring anything, you're counting. So, how many of you are psych majors? How many of you are seniors? How many of you live in New York City as opposed to Long Island or Jersey? Okay? I'm counting here. I'm not measuring anything. I'm not measuring your senioritis, right? I'm not measuring your psych majorness. I'm counting. All right? So you can have categories of anything, of gender, of race, of hair color, of major, of year in school, of whether you're married or unmarried, right? All of those are different categories in order to be able to pigeonhole people or your subjects. So you're just counting, okay? Is that clear? Do you understand? Those are category or nominal data that you're dealing with. And there are certain statistical tests that are used with those. One of them we're going to do on the very, very last night of class. All right? A second scale of measurement is the ordinal scale. The ordinal scale. This your book calls magnitude data, where you're measuring and you're answering the question, how much of something do I have? All right? So that's the interval scale and the ratio scale. The interval scale and the ratio scale. So these two scales are what your book refers to as magnitude data, interval and ratio. And here you really are measuring something. All right? Now, with both interval and ratio data, the differences between the data points are the same. They're all consistent. So the distances are the same. Unlike with the ordinal scale, where there may or may not be the same. Okay? The ordinal scale, think of it like a horse race, right? So the horses may come in one after the other at the finish line, or you may have 3 horses and then a long time until the next horse, right? And then another one soon after, and then a long time again. So when you have rankings, when you have ordinal data, the spaces in between the ranks may not reflect the same amount, the same distance, the same difference, right? In terms of rankings. But with interval and ratio, the differences between the scores are the same. So if you're looking at something like temperature, right? You have 100 degrees, 90, 80, 70, 60, 50, 40, right? The distances between the scores are all going to be the same, right? With interval and ratio data. So what's the difference between the two? Ratio data have a true 0 point. Ratio data have a true 0 point. That's the difference. And that difference is a big difference, because with a true 0 point, you can really talk about ratios. If I talk to you about the Fahrenheit or the Celsius scales of temperature, I'm talking about interval data, because there's no true 0 point. If I talk to you about 90 degrees or 80 degrees Fahrenheit, say 80 degrees Fahrenheit, 80 degrees Fahrenheit is not twice as hot as 40 degrees Fahrenheit. Okay? It is because of the numbers, but in terms of temperature, which is the variable that you're measuring, you can't say to me that 80 degrees is twice as warm molecularly, physically, than 40 degrees. It's just not true, because there's no 0 point there. Do we have a scale of temperature that has a true 0 point, below which there's nothing? Yes, you do. It's called Kelvin. If I give you degrees Kelvin, I have a true 0 point. 0 degrees Kelvin, there's nothing below it. That's as cold as you can get. Okay? Right? If I talk to you about 0 degrees centigrade or 0 degrees Fahrenheit, can you get colder than that? Absolutely. Okay? Also people in Wisconsin, right? Minus 30 in Wisconsin, no big deal. Right? So what you have separating interval and ratio is that true 0 point. And with the true 0 point, if you're talking about degrees Kelvin, 80 degrees Kelvin really is twice as warm as 40 degrees Kelvin. Okay? Because you have that true 0 point. So you have to ask yourself, what is my variable that I'm measuring? Can I get negative numbers, or do I have a true 0 point? If I measure the length of this table, and I have length as my measurement, is that interval or ratio?
Ratio.
Think. Ratio, right? Because you can't have minus 10 inches. Right? Length doesn't come that way. Time, same thing. There's no negative time. There's no such thing as negative time. You have to find a way to go backwards in time. So time is also a ratio schedule, right? A ratio scale of measurement. Degrees Fahrenheit, degrees centigrade, those are interval scales, because there's no true 0 point there. You can have negative Celsius as a measurement. There's no true 0 point. So the true 0 point scales are ratio scales. The non-true 0 points, when you can have negative numbers, those are interval scales. Okay? And thus, these two scales, the interval and ratio, are what your book refers to as magnitude. Rank, order, ordinal is the ordinal scale. Categorical and nominal is the nominal scale. And as we go through the book, we're going to talk about various statistical tests that are appropriate for some not appropriate